Okay, now let's compute the following area that's in green, the shaded area in green. So here we have a square, and from one of the middle of the sides of the square, we have drawn a segment to the other side of the square. We also have created a circle that has a radius of a over 2. We're assuming that the side of the square is a. So here we want to compute this sector area, this shaded area here. In fact, this area here can be computed using calculus, but we can also do it using the sector formulas that we know from the geometry. So there are many ways to solve this problem, okay? But we're gonna solve it with what we know. So here we know this length is a over 2, this is a. We can find this side here, okay? We can use the Pythagorean theorem to find it, okay? So a quick way is to find the area of this triangle. So let's say this is A, this is B, and let me call this half here C. So I can find the area of this triangle. So I know the area of this triangle. So here the sides are A over 2 and A. So the area of this ABC triangle, so let's call it S. So the area of triangle ABC is 1/2 times A times A over 2, which is A squared over 4. Okay. I can also compute this one here. So I can compute this sector, okay, here. Okay. I can also compute this one. So now I see the idea. So the idea is the shaded area is the area of the triangle minus this one minus this one. So what's this one here? So if I can call this angle here alpha, and this is angle alpha as well, because this one is A over 2 and this one is A over 2. Therefore, I have an isosceles triangle. Okay? But this one helps me find this angle here. So this is the sum of these two. So this is 2 alpha. So I know this area here now. So the area of the sector ABD. So no, it's MD. The sector MBD. Its area is 1/2 times the angle, okay, 2 alpha times the radius, which is A over 2 square. So I have the area as alpha A squared over 2, A squared over 4, sorry. Okay, now I need to compute this area here of this triangle. Okay, I can use this side here and this side and this angle. This angle here is just pi minus 2 alpha. So I have the area of this triangle MDA. Triangle, this is sector. Triangle MDA. So the area of triangle MDA is 1/2 A over 2 times A over 2 times the sine of pi minus 2 alpha. And this one gives me A over 8. Sine of pi minus alpha is just sine of 2 alpha. Okay. So now I have everything. So I have the area of the triangle, which is, so the area of the shaded area here, it's gonna be the area of the triangle, which is a squared over 4, minus the area of the sector, which is alpha a squared over 4, minus a squared over 8 sine 2 alpha. So I can factor out by a squared over 4. I think I can. So I have the area is a squared over 4, 1 minus alpha minus sine 2 alpha over 2. Okay. So this is the area. Okay. So in our case, alpha can't be more than pi over 4. So you see, it seems that this one can be negative, but it can never be, because this angle here can't be more than alpha over 2. Okay, because this quantity can be negative. Okay, so but note that this angle can't exceed pi over 2. Okay. And there is another way to do this problem. Okay, so we can use calculus. If we take A as the origin, so what's this equation here for this line? This line is gonna be written as y to x, and the equation of the circle is centered at a over 2 is 0, and it's having radius a over 2. So the equation of the circle is gonna be x minus a over 2 squared plus y squared equals a squared over 4. Okay, so once we plug the y here, we can solve and we can find here this one here. In fact, we can do that. So we can solve x minus a over 2 squared plus y squared, which is 4x squared, equals a squared of 4. Okay, we can solve and get this point here, and we can integrate. We can integrate this area. So the area is the area. Let's call this angle here. So let's call it's gonna intersect when we solve this equation on these 2 points, alpha beta. Let's not call it alpha. Let's call it CD. Okay, so this value is C. So we're gonna integrate between C and A. Okay, it's gonna be between C, because we're assuming here this is the center. So it's gonna the integral is gonna be 0, and between C and A of this function 2x minus here we need to solve for y, and y is gonna be the square root of a squared over 4 minus x minus a over 2 squared. Okay, so dx, and once we do that, we can find the exact formula that we need. Okay, I think this is general idea of how to do this kind of problems. To be more precise, we have to sit down and solve and get exactly these values.